Coming up on this week's episode of TechSNAP, it's a special holiday edition where we go back through 2016 and pull out all of the juicy stories and lay them all out for you to snack on. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. This is a special holiday edition of the show, which is brought to you by our three fine sponsors, DigitalOcean, Ting, and iXsystems. I'll tell you more about those great sponsors as this here show goes on. Our live stream and all of the downloads over at jupiterbroadcasting.com are powered by the incredible Scale Engine. Check it out at scaleengine.com. My name is Chris, and this week, Mr. Jude joins us in clip form for a best of. I gave him the week off technically, although he actually went through all of these and hand-picked them, so I guess it's not really the week off technically, but we wanted to give you some of our favorite stories from 2016. And this one, the one we start with this week, is from episode 248, The Bicycle Attack.
So our first big story is the bicycle attack.
Dun, dun, dun. Yeah.
Yes. So security researcher Guido Vranken has published a new attack that affects all versions of SSL and TLS. He says, while the sound configuration of both endpoints of a connection is understood to prevent the decoding of the ciphertext to plaintext without having access to the private keys, transactions conducted over a channel embedded in TLS leak various types of information. So when you set up an encrypted connection between you and your bank or whatever, it's encrypted, and we understand that that means that no one can get back the plain text from it. However, there might be other information they can gain just by looking at the encrypted text, like seeing the timing of, all right, so you went to this page, and then you sat there for a little while and typed in your username and password, and then you sent a thing that was slightly bigger than a normal request, and that's probably because it got your username and password in it. And then you got a response from the website, and then we see a bunch of, downloading the little images for the website and the CSS files. And then here's, that transaction there is probably you getting your bank statement, and there's the second page of it or whatever. Or, if you're chatting on IRC, it's pretty obvious. All right, that was you sending a message, and that was you getting a message, and so on.
Right. Okay. Yeah, that's pretty clear.
Yeah. And so there's a lot of research has been formed on how to stack up these different knowns in order to meticulously reconstruct the user's actions, given that the encrypted streams are known to an observer who is or has been listening on the secure transmission between the two endpoints. So the general idea is because we know certain things about what's going on here, we can, make guesses or jump to.
There's certain logical leaps you can make based on observing the user, essentially.
Well, in particular, if you happen to know that they're going to a website because it's port 443 or whatever, then you can assume that the first chunk of the encrypted communications is an HTTP request in headers or an HTTP response in headers, and that HTTP always looks like this, right? It's it's a protocol. We know that it's always going to be laid out like that,
right? I've seen that a million times.
Mm-hmm. So in this paper, the author will show that for a presumably large subset of web applications, it's easy to infer the length of parts of the plain text or certain attributes of it from a recorded stream of encrypted messages. So just by watching the message going back and forth, we can tell how long certain fields in that might be.
Okay.
Having access to the private key is not necessary. In fact, the actual ciphertext embedded in the stream is completely irrelevant to the deduction, and simple entry-level arithmetic suffices.
I could probably manage that, Alan.
Where'd you find that picture of the...
The register found that. Yeah, the register found that.
That's awesome.
I thought so, too.
So this basically, the attack can allow a passive listener to determine the length of your password just by sniffing the encrypted connection. And by knowing exactly how long your password is, that significantly reduces the effort required to brute force crack your password.
Yeah, no kidding.
Right? Because if your password could be, any of 95 characters, and it could be 10 or 11 or 12 or 13 or 14 or 15 characters long, that's a lot of permutations to try. But if you know for a fact that the password is exactly 12 characters long, you've basically just cut the search space down by huge orders of magnitude.
Yeah.
You have like 95 possible characters to the power of 10 would give you all the possible combinations for 10 characters. plus all that to 11, plus all that to 12, and so on, from the minimum to the maximum password length. Whereas if you know for a fact it's a certain number of characters long, then you can do quite a bit with that. So the attack takes advantage of the known characteristics of HTTP transactions, although it can be used against other protocols and for things other than passwords. We'll cover that a bit more. But it can basically determine the length of a specific field. So in a regular HTTP form post, like not an encrypted one, but when you basically submit a form on a website, it does a regular HTTP transaction with the regular headers and a post, but the data section is basically just URL encoded string. So it's like, username equals Alan and password equals correct horse battery staple, and then whatever the name of your submit button is in your most basic simple form, right? So when the form is submitted over an encrypted connection, HTTPS, that text isn't visible because it's encrypted. However, the length of the whole packet is known, right? It's one of the headers in the SSL part, because to decrypt it, you need to know where it ends. And so by knowing how long the entire encrypted message is, and if we know how long the message would be if it didn't include the username and password, right? We know what all the other fields are.
Yeah.
Then we can basically just subtract. Right, so if we know if a login sent with a username that's 8 characters and a password that's 10 characters is sent, and it adds up to 123, then one with a password 1 character longer is going to be one byte longer in the encrypted version. Now this depends on using a stream cipher instead of a block cipher, where it's padded to chunks of like 16 bytes at a time. But anyway. But if the length of the form field names, like the actual name of the box where you type your username and password, is known, and the target's username is known, then the only variable left in that whole transaction is the length of the password. And so that's all it takes to figure out how long your password is. So the attack kind of requires a bit of knowledge about the target. Like ideally, you'd want to know their username. But if you're the NSA and you're targeting someone, you know what their Twitter username is, or their Gmail account name. Right. It's their email address or their username. It's usually
you presumably
not usually secret.
You presumably have eliminated a lot of the variables because you're probably targeting a specific site, service,
right?
Something.
Yeah. So this basically requires knowing the site fairly well and having visited it yourself and measured what the fields are. And it also one of the complications in the headers that get sent from the user along with their password is their browser user agent string, which can be different for depending on what plugins they have, what version of the browser they have, all that. But if you are passively listening to the user's internet connection, if you happen to see them go to any not encrypted site, you would get that information very easily. And even if you don't know it exactly, if you can get a big enough sample of them going to web pages you know about, you can, it's like, I know the request for this is always this long, and theirs was this long, so it means their user agent string maybe was 4 characters longer than mine, or whatever, right? The paper gets into more detail about how it actually works. So yeah, the attack requires knowing a bit about the user, but for a targeted attack, that's really not that hard.
Yeah.
The other obvious wildcard is like the length of the cookie field. But if you can just intercept them loading something like an image or a CSS file off that website, that cookie is sent there too. And just by comparing the difference between your version of it and their version of it, you get what you need in order to figure out what it would be. And so yeah, and then once you know exactly how long their password is, it's a lot easier to start working on cracking it, or even just compare it to a dictionary of known passwords or something, right? Like if they're like some people, then they reuse the same password for a lot of sites. Right. So if you know they have these 10 possible passwords, right? But if we try to log into this website and get it wrong 3 times, we're going to get blocked. So we're not just going to try guess all 10. Yeah. What we'll do is look at the thing and find out how long the password they're using for that site is, and then it's easy to find it on our list. The other thing is, because of the nature of the attack, it also works against previously recorded sessions. So if you're the NSA and you recorded every encrypted session that this person has for the last couple of years, you can use this attack to go back and look at old ones. The complication there is maybe the website's changed, and so it'll be slightly different. And obviously, their browser string will change every so often.
What about possibly employers capturing at the firewall level and then going back and...
Lots of stuff like that.
Yeah.
And they mention here that it may also be executed on a larger scale using a Tor exit node, or VPNs, or proxies, or other internet traffic conduits in order to detect weak or short passwords susceptible to brute force or an attack based on a dictionary of often used passwords.
This sounds like something law enforcement would love to do if they got their hands on an important couple of Tor exit nodes.
Yeah. Huh. There's also a nice explanation of why it's called the bicycle attack.
I was going to ask, yeah.
So it basically said, if you get a bicycle for Christmas and it's wrapped up and it's under the Christmas tree, it's still pretty obvious that it's a bicycle.
Okay.
Just because you wrapped it up in encryption, you can still tell that is a bicycle.
You know what? I'll go with it. Good enough for me. That's right? Pretty good.
It's like, he only named it because it makes it easier to talk about. That's the part I kind of do agree about. At least he didn't make a logo for it.
Yeah, I'm sure somebody will, though. Although the register was working on something. I just don't know if they quite nailed it. I think they got close, but...
that doesn't really say bicycle to me, but that does... I love that just by, it's just black boxes going across the internet, but we can just tell that there's passwords in there.
Yeah. It's a good metaphor. Oh, that's interesting.
So the paper also talks a little bit about what you could do to try to mitigate this, like including... some random data in every post that's a different size so that it hides the length of the password. But they're like, if you just use a random sized padding, then extra field, then if I just get a large enough sample, I can figure out the range of those padding and probably narrow it down anyway. And, if I watch you log in 5 times and notice the differences, I can eventually figure out how long your password actually is still. So then it was like, well, what we could do is in JavaScript or something, after you type in your password, when you hit submit, it would actually pad your password out with null bytes or something all the way to, say, 1,000 characters. And then, the password field that actually gets submitted will always be 1,000 characters, but the server on the other side knows everything, only consider up to the first null byte and then ignore the rest. Although it's curious to see what some applications would do if you started sending null bytes in the passwords.
Yeah, that probably would take some troubleshooting.
Then the paper goes on to describe how you could do this for other things, like GPS coordinates. Just because they're encrypted, but just by knowing their length, you can guesstimate where in the world that could possibly be. If you have the PDF open, they have some maps where they kind of visualize what it looks like.
Okay.
It's like if the number of characters in the GPS coordinate is this many, that means it has to be in this little square in Africa.
I think I did see that.
Where 0 happens to be.
Yeah. I'll zoom in a little bit before I pull it up.
Or if it doesn't have at least this many characters, then it's definitely not over here in Antarctica. Yeah, so if the number of characters is exactly 2, then it has to be right there in Africa. And if it's 3, then it can be anywhere in there that's not that little block in Africa. Right? And then you scroll down, and it's like, if you happen to know that it's 4, then it can be any one of these places. So it's, Europe, but definitely not North America. Right? And, that right there could tell you enough to be interesting.
That would definitely be very helpful.
And then it does the same thing for IP addresses. If you had IPv4 addresses and they're encrypted, just by knowing how many characters are in the address, you can reduce the possible addresses that it could be. If it's exactly 7 characters long, then it's only 0.00023% of the address space happens to be 4 single digits, right? And if it's even 10 characters long, so 1 with 3 and 1 with 2 and 2 with 1 or whatever, they show the different possible combinations there, that's still only 1% of all possible IP addresses. Right?
Yeah.
And as you get to the more common numbers, it's 31%. But just by knowing the length, you automatically know that you're narrowed it down to 31% of the possible addresses. See right there.
Yeah.
And if it's 12 characters, that's only 16%. And so if it's if you know how long the IP address is, you've just narrowed down the possibilities a lot.
Right.
And you can probably also eliminate a bunch just because that one's not used or that one's only used in China, right? So
there's further.
If you know the even just the first set of digits of the IP address and then know the length, you've now eliminated down to a very small possible set to know who that is.
Yeah. That's not so bad.
So this is a very interesting attack, and it's, it's not really a bug. It's just the way it works.
Yeah, I wonder, when you see research like this, you think to yourself, I bet there's teams that work for the NSA that's already figured stuff like this out a long time ago. And now we're just kind of catching up.
Well, in particular, this only works with stream ciphers, where, adding 1 byte to the input adds 1 byte to the output. Now, the input and output aren't necessarily always the same size because you can meet some overhead, but the sizes do correlate. Whereas with a block cipher, there's padding, and it's always an even number, like 16, always divisible by 16 bytes.
And the paper points out, too, that if you hash before transmission, like using some JavaScript in the browser, so that way the password was hashed locally before.
So if you don't send the password but a hash of the password, then everybody's password is going to be the same length.
Yeah.
The problem with that is, on the other side, you don't actually want to know the real password, right?
Right.
You want to only have a hash, and it gets a little more complicated.
Yeah, it does. Interesting. Alan, any other thoughts on that story?
No, that's about it for that one.
In episode 249, we talked about an OpenSSH flaw, and anytime there's an OpenSSH flaw, my ears perk up. Whenever we start out with an SSH flaw, it's going to be something applicable to the interest of our audience.
Have we ever had one before?
I think there was one other one that we did as a news story.
Yeah.
Yeah, they're
doesn't
pretty
happen
rare.
too often. Yeah, it's kind of like a special event.
Quite a bit of work on it. One of the important things is that OpenSSH is kind of a monoculture. There aren't many other SSH servers that anybody actually uses.
So it's a big deal.
Other than like tiny ones like Dropbear that are in embedded things, but
right, yeah.
And that one's also horrible, or much worse.
Well, yeah.
Anyway.
Yeah, so that's probably where we should start today, don't you think?
Yes.
All right, let's talk about it.
So they announced 2 critical flaws in OpenSSH today. The first one, CVE 2016-0777, is an information leak or memory disclosure can be exploited by a rogue SSH server to trick the client into leaking sensitive data from the client memory, including, for example, your SSH private keys.
Uh-oh. No good.
Big deal.
Yes, no good.
Yes. So a commercial vendor contributed code for a feature called roaming, which was introduced in OpenSSH 5.4 that could allow broken SSH sessions to be resumed.
Right.
The idea that, if you're on your laptop, bouncing through Wi-Fi or your phone,
connected over
and
your
you
phone,
momentarily get interrupted.
Which happens. That's my work case sometimes.
There's workaround things like Mosh or whatever.
I was going to mention that. That's what I use.
But it's like building it into SSH seemed like an interesting idea.
Yeah.
So the server side of this was never in open source SSH, I don't think.
Okay.
But there's a commercial server that did support it. But it turns out when they added support to this, they turned it on by default, which is kind of makes sense, but it's also kind of not the way it's normally done with a new feature, especially something critical like OpenSSH.
Especially for, exactly.
But it turns out there's a bug in this feature that could allow it to, a malicious server to be able to read memory from your client and steal information they shouldn't have. So as a workaround, they recommend you can add this line to your config file there with use roaming no, and your SSH server or client won't use roaming anymore.
This was introduced a while ago then.
Yes, it was in OpenSSH version 5.4.
Yeah.
And the latest version is 7.1.
Right. So it's been something that's been floating around, turned on. Yeah, that is really, so many things usually get turned off by default.
Well, especially something like this. Although to be useful, it would need to be on by default, because if all your SSH clients don't support it, it's not going to help you resume very easily.
Sure.
Although really, if you, it can be turned on per session with a command line option, or per user with a user config option, right? So it seems like it would have been better, especially just that the OpenSSH server doesn't support it, and so, how many times your OpenSSH client make a connection to the commercial SSH server? I don't think very often. Anyway, one of the saving graces of this, though, is the authentication of a server host key prevents exploitation by man in the middle.
Oh, okay.
So this information leak is restricted to connecting to malicious or compromised servers. Because SSH checks the host key of the server on the other side, it means if you try to SSH to a good server, somebody can't intercept in the middle and steal your key by pretending to be that other server because they don't have the key. Right.
Right.
So, it can only happen if you're connecting to a server that is purposely malicious or is compromised and malicious.
Right. Okay.
Or if it's a server you've never connected to before.
Or maybe it's the first time you've ever connected from that machine if it's a new setup or something.
Yeah, something like that.
Okay.
Yeah, the chat room points out this is kind of almost like a heartbleed of OpenSSH because it's a feature that sounds interesting, but nobody's actually ever using, and it's on, and it caused this problem. Right? It seems like it needed more review before it got in the first place, and that probably should have been off by default unless people wanted it.
So how serious would you say this is?
Not that serious if you're not connecting to random malicious SSH servers, right? Because if you're only connecting to servers you control, as long as those machines aren't compromised and somebody hasn't messed with your SSH daemon, then they're not going to use this feature. And you can turn the feature off in your global SSH config, but you can also turn it off per client, like by setting in the .ssh directory in your home directory in the config there, you can turn it off for your users. So even if you're not root on the system, you can make sure your client never uses that. Although if you're using SSH keys on a server where you're not root, then root probably can get your key anyway. So, but in the meantime, it means you can definitely turn it off even if your sysadmin hasn't got around to turning it off yet.
Okay.
And you can also turn it off with a command line switch. -o use roaming equals no.
Okay.
And so it's fairly easy to work around. And they've got new versions coming out. So the latest OpenSSH 7.1p2 is out and should be in most package repos now or very soon.
Yeah, I'd imagine.
Yeah. And so there's that. The patch just disables the feature, but basically changes the default to be off instead of on. It's unclear whether a future version will go about actually removing all of that code altogether, or if they'll just try to fix the problem. Or it's not clear whether it was like a design problem with the way it works and there's not a way to fix it, or if it's just a bug in the implementation.
A bug by default?
Yeah. And then there's a second vulnerability, CVE 2016-0778, which is a buffer overflow, which leads to a file descriptor leak. And can also be exploited by a rogue SSH server, but due to another bug in the code, it's possible that it's not actually exploitable. Gotta love a bug like that.
Oh yeah, that's a good one.
And even if it wasn't for that, it's only exploitable under certain conditions, which is the non-default configuration, where you're using proxy command, forward agent, or forward x11. So if you're not using any of those features, then it can't be exploited. The only one I've used of those is proxy command, which I think we did in a tutorial on BSD Now on how to deal with a jump host. For example, when I'm using my laptop and I'm at a conference, I can't SSH directly to most of the servers at my house. But what I can do is SSH to my router and then from there SSH to individual machines.
Right.
And there are commands in my config file on my laptop which will do it automatically. So I just say SSH to, home file server, and it will actually SSH to the router.
Really?
And from there, yeah.
That's cool.
You can actually configure the chaining like that.
That makes it nice and quick when you're sitting down somewhere at like a conference and just want to connect really fast.
Yeah, you
That's
just
nice.
set up a short name for it, and it'll, even if the usernames aren't the same all the way through the chain as well.
Yeah.
But it's very handy if you have to deal with secure networks and stuff.
That's a cool tip, Alan. Thanks.
Or a similar one is a bunch of the project infrastructure at FreeBSD.
Yeah.
Because IP addresses are hard to come by, some of the jails are v6 only. So if you are somewhere where you don't have IPv6, you can't get in directly.
Yeah.
And so being able to hop through to a machine that has v6 to then get to that is very helpful. Although I have native v6 at home now, so I'm happy.
Boom.
Anyway, both of those vulnerabilities are fixed in OpenSSH 7.1p2, and we'll have to see what happens with the roaming support. It'd be really nice if somebody actually made it work and make it secure, and we could use it.
This is one of those patch your S stories, though.
But the big thing with
SSH here.
Yeah, the big thing with the roaming support is how do you decide when I'm going to come back and when I'm gone forever? Right? How do we avoid having a bunch of sessions pile up waiting to be resumed? maybe there's a timer. If you don't reconnect within 15 minutes, it goes away or something.
I have found that Mosh seems to work pretty well for me, and I don't know I don't know if it has a timeout. I don't know how that works, but I've disconnected it from one space here at the studio, gone home and reconnected, and just open the laptop back up, and once I have an IP, the session resumes. Mm-hmm. It's really nice. So I can see why they would want to build it in by default. The only thing that really trips me up is that it was turned on by default so long ago. Build it in, but turn it off by default. I mean, there's so many things when you go look at the server config for SSH that are off by default. This would just be one more thing that you would just, and then it would be an intentional act.
It's something FreeBSD is actually bad for, is introduce a new feature but turn it off by default, and then nobody ever uses it, and eventually the code rots.
Yeah, that is a problem too.
If you turn it on and it causes people problems, the problem will get fixed.
Seems like this particular kind of feature, though, just
this one isn't that a feature where you necessarily want it.
Yeah.
And so OpenBSD has a policy of normally turning on features by default, but usually those are security features where it's better to have that on by default. Mm-hmm. In this particular case, it didn't seem like it was. But if it wasn't for the vulnerability here, maybe nobody would care. Right? The feature's not supposed to be vulnerable, so whether it was on or off by default.
I suppose that's true. I suppose that is true. I guess the idea is that it's not vulnerable by default. But you never know, though. That's the problem.
Well, the other thing is apparently some of it might have been missing from the man page.
Oh, really?
And so not only was it off by default, but because it's not mentioned in the default config file. And if it's not in the man page, then how do you even know that feature's there?
Yeah, how do you even take advantage of it and learn about it? And how does the discussion about using it even ever start, right? It never even gets a chance to get going. Let's take a moment right here and thank DigitalOcean for sponsoring the TechSNAP program and making all of this shenanigans possible. Go to DigitalOcean.com, create an account, and then apply our promo code SNAPOcean. It's one word, it's lowercase, and it gives you $10 in DigitalOcean credit. You can spin up a $5 a month rig or go hourly, and it's unbelievable pricing. Super simple and fast to spin up, and an interface that'll blow your socks off. And they have a really straightforward API to match. DigitalOcean.com, super simple cloud hosting dedicated to offering the most intuitive and easy way for you to spin up a cloud server. Deploy in seconds, all SSD performance, lightning fast network, highly available storage with volumes up to 16 terabytes that you can attach to your droplet. And they have the best documentation on the web. I'm serious. Ubuntu, FreeBSD, Fedora, CoreOS, Debian, CentOS, you name it. You can run it just the base OS or an entire application stack. There's really nothing you can't do. Test something, put it in production, all of it. DigitalOcean.com, use our promo code SNAPOcean. And a big thanks to DigitalOcean for sponsoring the TechSNAP program all year long. Thanks, you guys. That really rocks. You guys rock. And thanks to everybody out there for using our promo code SNAPOcean for keeping us going. All right, let's talk about episode 260, Pay to Boot. Oh, yeah. I'm taking a stab at this first story. It's Russian ransomware, and we're thinking maybe Petya or Petya. Tell me about the Petya ransomware, Alan.
Right. So this one, other than in the article, they keep referencing DOS level. In general, it's quite nice. So this is basically ransomware, but instead of encrypting your files or anything like that, what it does is it encrypts your master boot record and sets it up so that instead of starting Windows, it starts the malware as the operating system.
Oh, so this is what classifies it as boot. DOS level?
Yeah.
Gotcha.
So it takes over the boot process and won't let you boot the machine until you type in a password.
It's like ransomware OS.
Yeah.
Okay.
So malware experts from a German security firm called G-Data have found a new type of lock ransomware that uses a DOS-level lock screen. I wish they wouldn't call it that.
I love it.
Since there's no DOS involved. To prevent users from accessing their files. Unlike most other malwares, the researchers didn't come up with this name. The malware actually came up with its own name because it has a website and a logo on the page where you go to pay the ransom.
What a great idea.
Yeah, so like I said, I'm not sure that DOS level really makes sense as a term for this. But yeah. So the latest lock ransomware discovered by security researchers is called Petya, which is being spread via spear phishing campaigns specifically targeting human resource departments at companies. The HR employees are sent an email with a link to a file stored on Dropbox where the applicant's resume or CV can be downloaded. The file is an exe file and usually called something like portfolio-packed.exe, tricking people into thinking it's a resume. And so the HR people open it and their machines get infected.
So I have a screenshot here where it says your computer has been encrypted. The hard disk of your computer have been encrypted with military-grade encryption algorithm. It is impossible to recover your data without N special key. This page will help you with the purchase of this key and the complete decryption of your computer. The price will be doubled in 6 days, 13 hours, 43 minutes, and 10 seconds. And then you click start.
This is the website where you actually pay them.
That's pretty intense with the countdown and whatnot. Now, my question to you, though, is does this website load in their malware OS or
no? I think you need a separate computer to do it.
Yeah, so you only get as far as that text-based environment. Okay.
So what it does is when the malware runs, it encrypts your master boot record and then blue screen of death your computer to stop it.
Classy.
Then
Nice.
when it starts up, it starts a fake check disk where it's actually going through and encrypting your files.
Oh,
and then
brilliant.
after that,
Brilliant.
It reboots and you get the lockout screen. So yeah, as soon as the user restarts a PC after the blue screen, the computer will enter a fake check disk process. After that finishes, it loads the Petya lock screen. Restarting the computer over and over will always enter the screen. The screen provides a link to the ransomware payment site hosted on Tor. After the user purchases a decryption key, they can then enter it at the bottom of the lockout screen. Petya claims to encrypt users' files, but GData said that they couldn't verify that claim eventually. But later, Trend Micro researchers took a look at the Petya malware and confirmed that the ransomware does encrypt files and also reveals that it alters the master boot record, preventing users from entering even in safe mode of Windows, which usually you can use to get around some of these lockout type things. And it asks for 0.99 bitcoins, which is about $400 as a ransom. But as you saw, that ransom will go up if you take too long to pay.
So Trend Micro is confirming this. And yes. I just noticed there's a video out there of the process happening, and I watched the check disk screen come up. Now it happened pretty fast, so it was hard for me to read the whole thing. But I'm sure there was probably maybe a mistake in there. But what I saw, if just glancing at it, I said that looked like a legitimate check disk. Which, if you think about it, if your Windows PC crashes and then it reboots and starts doing a check disk, and then it reboots after that check disk, that would be a expected behavior. And so if you're just like, oh, what? And you're kind of glancing over it as your machine's booting up, because you're like on your phone now tweeting about how Windows is crap, and then you look over at your screen, you see the check disk, and you're like, now it's checking my files. I probably lost something, hashtag thanks bomber tweet, right? And then it reboots, and you get that crazy flashing screen, and it is... you are just like that red skull and crossbones flashing at you that says press any key. That is dramatic. That works. I like it. I mean, I like it from like it's horrible and it.
If you look at if you pull up the Trend Micro link, there's a video.
Yeah, I played a little bit of that video while you were talking about it.
Yeah, it's pretty.
It flashes pretty intense at you. Yeah.
Yep.
And the one thing I did note is it does, like if you have UAC enabled, it does ask you to confirm the prompt. So it's doing it. It has to have administrative level privileges in order to execute from within the Windows environment to overwrite your boot record. So that would seem to be its Achilles heel, is if you are separating your privileges out properly, you may avoid this just by that. Do you think, or am I misunderstanding?
Yeah. So basically, you have to fall for the malware.
Yeah, and authorize it unless you have UAC turned off or something.
Right. But, you get that every file you try to run.
Yeah, that's true. And
now, if it had actually been a zip file or something, and if the user knew what they were doing, they would have known that, hey, this is weird. Why is someone sending their resume to me as an exe file? But part of it was clever of them to put the file in Dropbox so that people would be able to just... or so that people would think, oh, this is a trusted site, kind of, right?
Right, and it would be also if you're watching traffic, if you start seeing stuff go up to Dropbox, that's normal traffic. That's expected as well. A lot of expected things that you would just not paying a lot of attention to, just accept.
HR people are kind of getting to the point of expecting people's resumes to possibly be on Dropbox, right?
Sure, absolutely, I would think so.
So the other thing, the graphic you were just showing there is apparently the boot sector encryption is fairly simple. They're actually just doing XOR encryption with the value 0x37, which is just the ASCII code for the number 7. So they're just encrypting your master boot record with the number 7.
But the issue isn't necessarily the master boot record so much as the data on the drive that is then encrypted once it...
and it turns out then they separate... it seems maybe... To be faster, instead of encrypting individual files, they encrypt the master file table of the NTFS thing, because that's only a couple hundred megabytes.
Yeah, I noticed in that video it goes very fast.
Every file. Yeah, because it's only a couple hundred megabytes, but it will block access to every file. Now, some recovery software might be able to find, I found a whole JPEG,
right?
But it won't know the file names or anything.
Yeah, boy.
And apparently the key is a little more complicated. They're not just XORing with 7 the master file table, so it's not like you can just recover easily. But there's a bunch of links in the show notes if you want to see more about how it actually works internally.
Yeah, the chat room's talking about right now about how so many folks have UAC disabled as just a matter of course. Regular folks at home, offices. Yeah, I wouldn't recommend it.
No, I definitely wouldn't recommend it.
But, in my time of doing IT support, I saw it a lot.
I do have it set so that it doesn't do the whole black the screen and switch to a different desktop first.
Gosh,
But it does not run it until
you approve it.
So.
I recall most commonly it was software compatibility that caused people to disable it, and then secondarily it was the issue of sometimes the UAC prompt would hide behind active windows.
Now that was the whole point of UAC being captive. It jumps to the front and blacks out and won't let you interact with anything else until you answer it.
But have you seen the behavior where it actually failed, even when you have it still enabled? Have you seen the behavior where it fails to actually black out the whole screen and it especially happens a lot during installation of really old applications where the UAC prompt fails to come in front of the installer, so the installer hangs.
Windows 8, it goes to a different desktop environment.
Yeah, now I'm not so sure if it's... I'm more referring... My experience would be more in Windows 7. So I'm not so sure about 8. But that was... But what my point is in my day, that was the reason why people disabled it a lot, was because there would be Internet Explorer functions that would need to install something in the background every time they loaded, and the UAC prompt being in the background, even though they could have just tabbed over to it, the UAC prompt being in the background and the user not knowing was enough for them to just disable it altogether. I think that's pretty common. Our next story is a great example about some of the tech that we rely on underneath the hood that can leave us massively vulnerable. We're going to talk about that, but first I want to talk about iXsystems. Go to iXsystems.com/TechSNAP, and thanks to iX for sponsoring the TechSNAP program. If you've got a small office or a huge enterprise and anything in between, iXsystems will build you an incredible workhorse powered by those great Intel processors. iXsystems.com/TechSnaps, where you land to support the show and get their white paper if you need to convince people in your business. Here at Jupiter Broadcasting, we've got a free NAS Mini, but they got systems for all sizes and workloads.
For over 20 years, iXsystems has been the go-to company for storage and servers driven by open source software. And we're also the developers of FreeNAS. With our unique convergence of hardware, software, and storage expertise, we bring you the award-winning TrueNAS hybrid flash and all-flash storage arrays, offering enterprise reliability and performance at a value unheard of in storage.
From FreeNAS up to TrueNAS and all of the compute jobs in between, check them out at iXsystems.com/TechSnap. A big thank you to iX for working with the TechSnap program now for a couple of years, making such great products, and all of the great success stories that we hear from our listeners who try them out. So I was teasing about that technology under the hood that leaves you vulnerable. Well, of course, I was referring to ImageTragic. ImageTragic? What's ImageTragic?
ImageTragic.
What's ImageTragic? What's ImageTragic?
So there's an application called ImageTragic.
Yeah, I'm familiar with ImageTragic.
ImageTragic is a very popular suite of applications for working with images.
Right.
And it's used by a huge number of websites to do things like convert, process, and resize images that are uploaded by users. Whether it's a forum letting you pick an avatar, or like your profile picture on Facebook or Twitter, or uploading images and making thumbnails of them for a photo book or whatever it is.
It is literally the back end magic for processing images.
There's another library called libgd, which is different and so on. But yeah, ImageTragic is a huge thing used by a lot of software. And it turns out there are multiple vulnerabilities in ImageTragic, which is used to process these images. And one of the vulnerabilities can lead to remote code execution if it's processing user-submitted images. So it means if I go to your forum and upload an image that maybe isn't actually an image, it's something else, then I can run whatever commands I want on your web server. I'll just take a copy of that database, that your configuration file that gives me the username and password for your database, and then I'll be like, dump that, and then send it over here. And
What's
now
going
I have
on?
your whole database or whatever.
That is a mess, Alan.
Yeah. So if you use ImageTragic or any other library similarly afflicted, we recommend you mitigate the known vulnerabilities by doing at least one of these two things, or preferably both. First, verify all images files begin with the expected magic byte sequences. So when you get, a PNG or a JPEG, the first couple of bytes of the file tell you what type it is. And that's how programs can tell that, that's a PNG file, and this is how we should process it. So this way, if somebody sends one of these exploit scripts and names it .png, you will detect that it's not a PNG and not process it. The other one is use a policy file, which is a configuration for ImageTragic, to disable the vulnerable coders that are part of ImageTragic. The global policy for ImageTragic is usually in etc ImageTragic, and they provide an example policy file on the website there to disable the ephemeral URL, MVG, and MSL coders. So ImageTragic released a new version, 6.9.3-9, on April 30th. But it's not clear if it actually completely resolves the vulnerability. It does. It fixes some of it, but maybe not all of it. Well, because they don't know if it's still possible to exploit it.
Okay.
You have to read the website there, ImageTragic.com, which is what they've named the vulnerability.
Kind of cute.
They have a FAQ there of why they ended up naming it. Because originally they started with just a blog post, but nobody was paying any attention to it. And then they went and bought the domain and got a logo, and then all of a sudden everybody was paying attention.
Oh no. Dang it, people.
Yes. But yes, they say insufficient filtering for file names passed to delegate commands allows remote code execution during conversion of several file formats. In particular, ImageTragic allows you to process files with an external library. So if ImageTragic can't handle a certain type, you can have it call a different program. This feature is called delegate. It is implemented by basically forking out to the shell and running some command. And then there's a configuration called delegates.xml with the actual values for the different parameters. Due to insufficient checking on the %m substitution, it's possible to conduct shell command injection. So basically, if one of the delegates is download a file from the internet, it would be like, wget blah, 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 -o to this file, and then here's the URL. Except for instead of, example.com/blah, you put example.com semicolon ls -al, and now that command runs instead.
That's pretty clever. Pretty easy.
Yeah. So it runs your command in addition to the normal operation, allowing the attacker to do whatever they want. So I saw an example online where it's like you process this PNG file and it prints out a big scary warning saying, hey, actually, in addition to processing this PNG file, we also owned your machine. The most dangerous part of ImageTragic is that it supports several formats like SVG and MVG, and probably some others, which allow to include external files from any supported protocol, including delegates. So basically, an SVG, for people that know, is the scalable vector graphics. And the reason why SVGs are awesome is you can resize them to any size, and they keep 100% of the quality. Because what an SVG actually is basically an XML file saying draw these shapes. So, if you make your logo as an SVG, it'll be like, so there's a circle, and then there's a triangle, and a triangle, or whatever. It's basically a bunch of instructions on how to draw it, and then you can just scale that to any size, and it redraws it at perfect quality. Whereas with a regular like JPEG, if you resize it, it looks like ass.
Right. It's blurry.
Yeah. So the thing is, SVGs and MVGs can have includes and so on. Like if you scroll down a little bit, you see the MVG there, you can say, look, I'm going to include some file or
file_read.mvg.
And a bunch of these other ones. And so they can include remote files from websites so that the attacker can get more code injected into your system, or they can use it so that when ImageTragic is done processing the image and gives you the resized image to download, the content will actually be some file that's read off the hard drive of your web server.
That'd be a great way to return, like in this case, Etsy password.
Exactly. And so it's like, oh yeah, I just downloaded avatar.png, except for actually the content is your password file. Yeah, so there's a bunch of vulnerabilities, and you should check out the website for more details, and you should update your ImageTragic, but also keep an eye out for the next couple days. There might be a second update to fix this better or more correctly, or the rest of the way.
I was looking at some of the stories you've included in the show notes, and like all of them pretty much have updates from like the last 24 hours of stuff that's been going on. So yeah, this is still happening, still going on right now.
Yes. So there's also, as part of the FAQ, they ask, why are you disclosing the vulnerability like this? Why is it not, coordinated disclosure where we tell everybody, hey, you need to watch out and update ImageTragic.
Right.
And then, don't tell anybody what the problem is until later. They say, we've collectively determined that these vulnerabilities are available to individuals other than the persons who discovered them. An unknowable number of people having access to these vulnerabilities makes this a critical issue for everyone using the software.
In other words, it's already out there?
Yeah. They're pretty sure it's already out there. And
who is us in the FAQ, it asks, and it says us is we. We is us.
It's the people that were working on it. There was somebody from a Russian mailing list and somebody else.
Putin? Probably Vladimir Putin.
Some people working on stuff.
My ImageTragic. No, don't dot my ImageTragic. No, that's supposed to just run in the background and something I'll never have to think about. Come on, Alan, what are you doing here? Well, thank you for telling us about this. I had seen ImageTragic floating around, and I had not seen what it was about. I figured there was something afoot. I do kind of like their logo and site, ImageTragic.com.
Yeah, well, the wizard is, I think, based on the regular ImageTragic.
Right. That's good. It's good.
Yep.
It's funny that they say they didn't get much traction until after they launched the name. And now they have, of course, a Twitter account. Let's see. Their Twitter account's only got 345 followers, though.
Well,
yeah.
I'm not expecting many updates on this vulnerability.
No, but you know what else is interesting is not only would this be a great way to get it, but look what the actual name of the account is, the CVE name.
Yep.
That is actually pretty good. I'm going to follow it just for that. Boom. Followed. Pow. Because I think that's clever. All right. Well, why don't we take a moment?
I'm going to go register every CVE number for the rest of the year.
Oh, right. Yeah. Yeah, what you need to do is just think of really good puns on open source project names and then just register a few of those.
And then have them ready and be like, hey, has your security company found a flaw in this tool?
I'll tell you first. You want a great name?
Domain,
right?
And I've already made up a logo for you.
Dude, it's the new gold mine. You just got to get to the right one.
Oh, ImageTragic, how you wronged us. But let's reset. There's something else we need to discuss. First, though, there's something we got to tell you about, and that's Ting. Go to TechSNAP.ting.com to get $25 in service credit or $25 off your first device. $25 will likely pay for more than your first month of Ting because it's mobile that makes sense. You only pay for what you use, your minutes, your messages, and your megabytes, and that's it. $6 a month for the line. Imagine if you're a small business. That's so awesome. Radically great customer service. 2 different networks, CDMA and GSM. They don't bother interfering with updates. You get your patches. You can go get a device from the Play Store or wherever that's compatible and bring it, or you can buy it directly from Ting, or just get a SIM card. And I'll give you a little Ting pro tip. Follow them on Twitter. I don't just say that because they would like me to say that because they've never even mentioned that. But really, this is how you can get some great giveaways. Because it's not like you got something better to do than get a free phone, right? Everybody could use a free phone. They were giving away a Moto G4 not too long ago, and if you were following them on Twitter, you knew about that. They're just at TingFTW on Twitter. TechSNAP.ting.com. That's where you go to get a $25 discount and support this show. Big thanks to Ting for sponsoring the TechSNAP program for quite a while now, too. Happy holidays to Ting. Hoo-wee. All right, so I was giving ImageTragic a hard time, but there was that whole curl bash thing that we covered in episode 266 of the TechSNAP program. I was digging around the show notes. I looked ahead, and
I love this next one. A lot of times, I'm guessing just from kind of what I read ahead, a lot of times you see people that will just like take a command on line, copy and paste it into their terminal and run it, which is a bad practice.
We've shown before how with some JavaScript, you can actually make it so you highlight some code and copy, and when you paste it, it's completely different code.
Yes.
We've shown that on the show before.
Yes.
But the newest thing that lots of tutorials and or the installation instructions for stuff do, worse, the installation instructions for Intel's kernel hardening tool are this. Literally, it's like, so curl some URL of a shell script pipe bash.
Yeah.
Right?
I've seen a lot of those.
Download this script
Yeah.
and run it directly in bash, and that'll install this application for you.
This is kind of common on
the new, fake DevOps, way to install things.
That, and I'm going to just take one here. I'll just admit it too. The Linux desktop is kind of a clown show for installing software if you want to target a whole bunch of different distros. And so if you want one universal installation, sometimes it's just a good old shell script. And so sites will just have download this and run this, and it's basically that. It's a shell script that you just execute as root. It adds repos, adds keys, installs software.
Sure, and that is terrible. But this one we're actually talking about piping the result of the curl directly into bash.
That is
not even looking at the file or downloading it or verifying that it's right.
That's just warp speed ahead.
Yes. We've laughed at people before because of this, because if you're not doing it over HTTPS, somebody could do man in the middle and replace the shell script with something different. Mm-hmm. So this one over at idon'tplaydarts.com, which is a good way to phrase this kind of stuff, is I don't play dangerously when I'm doing a sysadmin. But it's like, if you think doing curl pipe bash is okay, you shouldn't have root access. Installing software by piping from curl to bash is obviously a bad idea, and a knowledgeable user will most likely check the content first before doing it. Right? So people are like, so I look at the URL and see what the script is before I run it. So wouldn't it be great if the malicious payload could only render when piped into bash instead? So when the admin looks at it, it looks fine. It's a perfectly safe shell script. When you pipe it into bash, you get something completely different.
Evil.
So we all know it's bad, but some people do it anyway. They tell themselves it's all right because they're checking the content. But that only works if you end up downloading the same thing as you would actually, and piping that into bash compared to what you actually reviewed. So luckily, the behavior of curl and wget or whatever else changes subtly when you pipe it into bash. This allows an attacker to present two different versions of their script depending on the context. It's not that the HTTP request from curl when piped to bash looks any different than any other that's piped to standard out. In fact, for all intents and purposes, it's identical, right? So the bad guy can't just, if it's curl, send this different thing, because maybe that's what you're going to use to look at it and see that it's fine before running it. Mm-hmm. And as far as the web server can tell, just by looking at your request, it can't tell if you're piping it into bash or not.
Right.
Luckily, execution in bash is performed line by line. And so the speed that bash can ingest data is limited by the speed of the execution of the script. That means if we return a sleep at the start of our script, the TCP send stream will pause while we wait for the sleep to execute. This pause can be detected and used to render different content streams. Right? So if the shell script starts with sleep 10 and then some other commands, as we're sending the data to the user, to the curl, eventually curl's the send buffer is going to get full, and the receive buffer will be full, and curl's buffer will be full, and the window back to the application will be 0, and no more data will be sent. But if you're doing it to, say, your console, it's not going to do that. It's going to just, all the data will flow through because it's not being blocked. Mm-hmm. So by using a sleep at the top of the script, we can create this blocking action that we can then detect on the server, and only when we detect it, send the bad script.
Wow.
Unfortunately, it's not just as simple as wrapping, socket.send sleep 10 in a timer and waiting for a send call to block. The send and receive TCP streams in Linux are buffered on a per socket basis, so we have to fill up those buffers before the call to send will actually block. And we know and then curl has its own buffer for writing to the pipe. So it'll have downloaded data out of its local to the receive socket buffer and tried to put it into the buffer to the pipe to DD. Right, we got buffers all the way down.
Yeah.
So we have to fill all of those before we'll get back a window update with a size set to 0, telling us that we can't send any more data because it hasn't all been received yet. We've got the maximum amount of data in flight. The only character you can really use to print to the screen that won't show up when you're just piping into the console or looking at it in Chrome is the null byte, because it won't render on most consoles and won't render in Chrome if the character set is set to HTML or the content type. And so as we know, the content length data is transferred at the beginning, so we have to switch to chunked encoding so that we can have a variable length stream. And then we could just send strings of null bytes that are the same size as TCP7 buffer until we get the blocking action caused by the buffer being full. Or if we don't get it after a certain amount of time, we can just send the safe script. So the attacker sends chunks of nulls until all the buffers on the client side are full. And because Bash is sleeping and not receiving data yet, and then all the attacker has to do is give their different payload. So we can see when we just run curl, we get sleep 3, hello there, nothing. If we run it again, but pipe it into Bash, we get asleep and then troll face.
Yeah, troll face. I love it.
Which is your malicious content.
Yeah.
And so it detects when you do it wrong and burns you for it.
The source code is linked there too, which is great, which is just a nice touch.
Yeah. Curl Sleeper Agent. That's a good title.
So I wonder how the hell they thought of this. They must have just been sitting around going, how can we stop this? What can we do to make a point? Well, how can we prove a point? And then,
I'm
just
still
went from
just
there.
flabbergasted by when you go to get Intel's kernel hardening tool for Linux and the install instructions are curl pipe bash.
That is super disappointing, isn't
I
it?
was just like, oh my goodness, that is terrible, terrible, terrible.
Yeah, I guess, it's sort of a lazy way to do it. And that's just, there's no
It's like, I understand that it's really not any better than downloading a shell script and running it. But just by doing it that way, it just should only... It's basically targeted at people that shouldn't be sysadmins. If that's how you want it, if you want just one command and it works, you shouldn't be allowed to have admin access on anything.
Yeah.
Your own desktop, let alone.
Yeah.
Sir.
It's a little dangerous.
Yeah.
All right. Well, other than that little bit of, I feel like that's a PSA you just gave us there, Alan. Anything else on that story?
No.
Our next story in episode 270 of TechSNAP is about those brand new shiny PCs that you get that maybe aren't so shiny.
Yes. So it's a nice brand new computer you have there. Would be a shame if something happened to it. So Duo Security, which is a company that does a lot of security research and stuff, they've come up with a report, and according to the report published by the two-factor authentication company Duo Security, third-party updating tools included by default on your Dell, HP, Lenovo, Acer, or Asus Windows PC, which are the top 5 Windows PC OEMs in the world, are exposing those devices to man-in-the-middle attacks. So OEM PC vendors understandably need a way to maintain and install more of the aforementioned bloatware that they give on your computer, right? So the Duo Labs team investigated the OEM software update tools spanning the 5 biggest vendors, Acer, Asus, Dell, HP, and Lenovo. So this study was restricted just to the auto updaters included with the crapware, not the rest of the crapware itself, which can have lots of security problems.
Okay.
This is only looking at the security problems in the auto updaters for the crapware and the drivers and so on. Right? Every one of these OEMs now comes with, this thing that's supposed to, it's improve your experience and auto update drivers and latest fixes for things. No. So implementing a robust, secure system for delivering software updates to users requires a thorough threat model and a fundamental understanding of how to correctly use the various crypto systems available to do so. Many OEM vendors don't seem to understand or care about the need for basic security measures in their software, resulting in software rife with vulnerabilities. Whether it's a creep in the coffee shop Wi-Fi or a nation state sitting on all the right trunks, any software that downloads and executes arbitrary binaries and is an enticing target to attackers. This is well established from the fact that back in 2006, where some dude broke Mozilla's auto updater, or in 2010 when there was Evil Grade, or 2012 where the Flame malware authors discovered how to do a man-in-the-middle on Windows Update, or even January of this year where there was the Sparkle debacle on OS 10. This shows that targeting the transmission of executable files on the wire was a no-brainer for the attackers. So the big problem here is the software updaters go and call Lenovo and say, is there an update? But they don't do HTTPS. So anyone could pretend to be Lenovo by intercepting your Wi-Fi or wired connection and, basically send you an update that is actually malware instead.
Alan, it says here in the report too that they even tested signature PCs, which are supposed to be those PCs that are like crap free from Microsoft directly, but even those had OEM supplied software updaters and support packages that had flaws.
Yeah. So even if you pay extra for the Windows computer that doesn't come with crapware, the crapware auto updater is still there and still affects your security.
Wow.
Yeah.
Oh, jeez. Like, you feel bad for these consumers that there's just no reasonable expectation that they'd be aware of all of this. And so they're just suckered into a machine that comes loaded with, and here's the worst part, Alan? Not just software that enables man-in-the-middle attacks and things like that, but just software that slows down the computer to begin with. It's just so much salt in the wound at this point.
Yeah. Like I said, the scope of the research paper is limited to the OEM updaters and not the rest of the attack surface found on these systems. Basic reverse engineering uncovered flaws that affected every single vendor that they reviewed, often with a very low barrier to entry to both discovery and exploitation. Oof. So they didn't have to look very hard to find problems, and they didn't have to try very hard to exploit them. So on Dell's, they found one high-risk vulnerability involving a lack of certificate best practices that they've nicknamed a completely separate vulnerability, eDell root. So Dell basically gets in there and starts trusting a bunch of its own certificates that are, distributed improperly and could allow anybody to have make their own certificate that would be trusted by this that's auto-installed on every Dell. So that's bad. For Hewlett-Packard, they say the two high-risk vulnerabilities that could have resulted in arbitrary code execution on affected systems. In addition, 5 medium to low-risk vulnerabilities were also identified. For ASUS, they found one high-risk vulnerability that allowed arbitrary code execution, as well as one medium-severity local privilege escalation. On the Acer, they had 2 high-risk vulnerabilities that allowed arbitrary code execution, and Lenovo had one high-risk vulnerability that allowed arbitrary code execution. So they say, in general findings, they had every vendor shipped with a pre-installed updater that was at least one vulnerability resulting in arbitrary code execution as the system account, which is the even higher privileges than administrator, allowing for a complete compromise of the affected machine. So every new machine came with crapware and an auto updater for the crapware. The auto updater made the machine less secure, not more secure, as you would expect. The whole point of the updater is to patch the software, right? Not to mention that this report didn't actually look at the crapware itself, which is probably also full of problems.
They also talk about here too, like a lot of these do silent updates. Not all of them, but enough of them do. Some of them, they use ridiculous obfuscation and pointless encryption features where they hide themselves in the registry.
Yep,
it's malware.
Yeah. There's very low level of technical sophistication required to exploit this. It was trivial to get in there. So they didn't have to work very hard. Like, I think one of these runs a local HTTP server that anybody can connect to and have it do stuff on your behalf. And that's, I think, what the privilege escalation
I think that was the Acer one.
Yeah. And he was like, oh, here, let me just connect you and tell you what to do. And you'll just start doing it because security is silly. They say vendors often fail to make even basic use of TLS, let alone properly validating update integrity or verifying the authenticity of the updated manifest contents. So yeah, on top of, if you use TLS properly so that you can verify the server you're talking to is actually Lenovo and not a nation state or the creepy guy at the coffee shop pretending to be Lenovo, you still need to either have the actual updates be signed, and so you can be sure that someone hasn't hacked Lenovo and replaced the update with something else or something, or at least have verification on the manifest. So you have a file that's a list of all the files you're going to download or whatever, and at least sign that so you know that this file should be this size and is actually from Lenovo.
So you talk about the trivialness of some of this. I guess what strikes me about this is two things. First of all, it's not shocking, I think, to any of us that there's this many problems. But I guess what is shocking to me is that we haven't really properly done this study before. How is it 2016 and we're just now getting around to this? And why is it okay that companies that are technology companies, this is what they do, is computers, software, and hardware, and they're screwing this up?
Well, I think in particular, part of the problem is that, Dell and Lenovo are not software companies.
Well,
And
very much so, right, yeah. Well, then they shouldn't be
so they
doing
hire
this,
a
though,
couple
right?
so they get a couple of people that aren't experts at it, and they're supposed to set up the secure updating system. But I think the biggest problem is these companies never cared about security before. And maybe more stories like this will get them to actually clean up their act.
Yes,
Of course, it gets even worse, right? So vendors sometimes had multiple software updated for different purposes and different implementations, some more secure than others. So even if Lenovo fixed their updater, they actually installed 3 updaters.
I like the Asus Giftbox Desktop. The Asus Giftbox Desktop introduces you to valuable pre-installed apps and exclusive promotions.
Yeah, so that's the other thing is that, this is how they make their money is
Yes.
These trials they get you to buy software and stuff. But yeah, multiple auto updaters for all the crap nobody wants on their computer anyway. What is it? The large attack surface presented by ancillary OEM software components makes updater-specific bugs easier to exploit in practice by providing the missing pieces of the puzzle through other tools bundled with the system. So even if the auto updater wasn't buggy enough to let me take over the computer entirely, the crapware included with it provides the rest of the pieces I might need in order to take over the machine.
Everybody falls down. HP, Lenovo, Asus, Acer, everybody.
Yeah. The top 5 manufacturers. So if you go to the store and buy a computer, it's probably exploitable out of the box.
Which means that the PC Windows ecosystem is more of a security nightmare than we even realized.
Yeah. I think part of the reason we haven't seen more on this before is that computer expert people often, first thing they do after a new computer is reformat it. Although with the way Windows distribution and licensing model has changed, you don't really get your own install disk to do it. Like you get a recovery image that includes all the crapware. So it's a lot harder to actually get a clean
these days. I mean, I think a lot of geeks would probably just buy a copy of Windows directly if they wanted to be legit and do a fresh install. I mean,
but then you just pay for 2 copies of Windows.
Yeah, I know. That's a crappy licensing model there, isn't it? But
not so crappy if you're Microsoft.
Dell, HP, and Lenovo, I just expected more from.
Yep.
I really did. They work so much in enterprise that it feels like they, out of all of these companies, should have.
Well, actually, I think it was Asus I expected more from. They have much more of a brand of being the, PC enthusiast tuner type people.
Sure.
Like I understand Dell loading their machines with crapware.
Yeah, I guess so. But even just basic things like file signature checks, TLS.
Yeah. It's not that hard to use HTTPS to, download your updates.
I mean, we're talking about this is super basic stuff they're not even doing.
Yep.
And then they're even going out of their way to make it harder. Fascinating story, Alan. Thank you for sharing that with us. Mm-hmm. That's a great out of the box. And ours has some additional coverage as well as who else is it? ThreatPost has some additional coverage, which Alan has linked in the show notes if you guys want to read up on that or share the story with friends, family, or companies. Because if you're a business and you buy a PC right now that is coming with some amount of bloatware, or I know I've gotten HP Enterprise and Dell Enterprise machines that absolutely come with updaters for drivers and whatnot.
Yep.
They might not come with all of the extra software installed, but they still come with their software to do that. Yeah, okay, but what about power in the age of the feudal internet? Power in the age of a feudal internet.
Yes.
Interesting, Alan. Should we start there? You ready to jump in? All right.
Yep.
Let's jump in.
Right. So Schneier's article here over at the
Collaboratory?
It's at the very bottom. It's called Mind. It's like the multi something. Anyway.
We are the Borg.
What's it said there?
I don't know.
In the gray part.
Oh, I see. The multi-stakeholder internet dialogue. Wow, that's catchy. That rolls right off the tongue, too.
Yeah. He says, we're in the middle of an epic battle for power in cyberspace.
Oh.
On one side are the nimble, unorganized, distributed powers such as dissident groups, criminals, and hackers. On the other side are the traditional, organized, institutional powers such as governments and large multinational corporations. During its early days, the internet gave coordination and efficiency to the powerless. It made them powerful and seem unbeatable. But now the more traditional institutional powers are winning and winning big. How these two fare long-term and the fate of the majority of the rest of us that don't fall into either of those groups is an open question and one vitally important to the future of the internet.
So to unpack that a little bit, he's sort of saying that the powers that traditionally weren't as predominant online are more predominant now, and in some of these cases they're states. Is that essentially what he's saying?
It was more that when the internet first started, it gave just disorganized groups of people the ability to organize and become very powerful. And big institutions didn't really, like governments didn't
Leverage it. Yeah.
Now the governments and big corporations are using the internet, and as he explains later, while the internet gave power to the people without very much power, what the internet really does is just amplify the power you have. So your very little amount you have, but when you work as a group, you can make it quite a big amount. But if you already have a lot, and then you add the internet, it just makes it even bigger. And so, yeah. This is,
Okay. Interesting point.
in its early days, there was a lot of talk about the natural laws of the internet and how it would empower the masses, upend traditional power blocks, and spread freedom throughout the world. The international nature of the internet made a mockery of national laws. Anonymity was easy. Censorship was impossible. Police were clueless about cybercrime. And bigger changes were inevitable. Digital cash would undermine national sovereignty. Citizen journalism would undermine the media, corporate PR, and political parties. Easy copying would destroy traditional movie and music industries. Web marketing would allow even the smallest companies to compete against corporate giants. It really would be a new world order, right? That's what we thought at the beginning of the internet. And some of that has actually came to be. You know, we have seen Facebook used to start revolutions in some countries, and a lot of this, you know, the way movies and TV and so on works has changed a lot because of the
And it seems almost every terrorism event these days has a social media component to it. Every activism movement seems to have a social media component to it that's pretty significant. And if you just want to take U.S. politics as an example, both U.S. presidential candidates announced their running mates via Twitter. That's pretty big. That's social media. Social media that's a pretty big deal to announce via Twitter.
Yep. It says, on the corporate side, power is consolidating around both vendor-managed user devices and large personal data aggregators. So to kind of demystify those two terms, a vendor-managed device mostly means a computer you don't control, like your cell phone.
Like a mobile.
Yeah. And large personal data aggregators are your Facebooks and Twitters.
And Googs.
Yeah, and Google for sure. It's a result of two current trends in computing. First is the rise of cloud computing, meaning that we no longer have control over our data. Our email, photos, calendars, address books, messages, and documents are on servers belonging to Google, Apple, Microsoft, and Facebook, and so on. And second, the rise of vendor-managed platforms means that we no longer have control over our computing devices. We're increasingly accessing our data with iPhones, iPads, Androids, Kindles, Chromebooks, and so on.
Yeah.
Even Windows 8 and Windows 10 and Apple's Mountain Lion are heading in the direction of less user control and more centralized control.
Yeah, especially like if you consider their cloud storage options like OneDrive and iCloud, which there you're not even managing the files anymore. You're just putting them in these object databases, and they're mounting it to your file system and giving you access as long as your credentials are good.
There's a point where, you know, Apple's erasing your local music and saying, oh, well, we have a copy of that in the cloud for you. So you
right, part of a music service. Yeah, exactly.
And that kind of stuff. And so Snyder says that I previously called this model of computing feudal. Users pledge allegiance to more powerful companies who, in turn, promise to protect them from both their sysadmin duties and security threats. It's a metaphor that's rich in history and in fiction, and it's a model that's increasingly permeating computing today. Feudal security consolidates power in the hands of the few. These companies that act in their own self-interest. They use their relationships with us to increase their profits, sometimes at our expense. They act arbitrarily, and they make mistakes. You know, we see there was an article a couple weeks ago where Google deleted a blogger blog that had decided violated its terms of service, and deleted this artist's entire history of everything they'd ever done. And because a lot of apparently a bunch of the images were only existed on that blogger, which is kind of their fault. But, we've seen the same thing happen where, you've got locked out of your Apple iCloud account or something, and they're like, no, we're not giving that back to you. And it's just gone, right?
Mm-hmm, mm-hmm. Well, what scares me is also, we have a story later on coming up about LastPass, but there's another example of a password storage system where there's an account credential, and there's all kinds of services like that. Absolutely.
But, especially it's about the arbitrary decisions where, at some point, somebody was live streaming with Justin.tv and they decide, we're shutting down and we're going to do just Twitch now, and it has to be about gaming or we're not streaming it.
Mm-hmm. Or like how YouTube constantly decides that videos that I've had up on YouTube in the Jupiter Broadcasting channel for 5, 6, 7 years are just getting flagged. I get 3 or 4 videos from our catalog pulled a day off of YouTube.
Yep.
And for some reason, all of a sudden, they're in violation because somebody else uploaded something to YouTube and they flagged it. It's just absolutely frustrating. No control. No option there.
Right. Whereas if it was your own website, you'd have a lot more control over what got pulled up and pushed down and so on.
That's the trade-off for being on their platform.
Yep. Government power is also increasing on the internet. Long gone are the days of internet without borders, and governments are better able to use the 4 technologies of social control: surveillance, censorship, propaganda, and use control. There's a growing cyber sovereignty movement that totalitarian governments are embracing to give them more control, a change that the U.S. opposes because currently the U.S. has substantial control under the current system of how the internet's run.
Sure, we like it that way.
As more countries are deciding they should have control over their part of the internet, that harms the internet. But at the same time, I don't think the U.S. government should have so much control over the internet either. And they say, and the cyber war arms race is in full swing, and is further consolidating government power. So he asked, what happened? How in those early internet years did the future go so wrong? The truth is that technology magnifies power in general, but the rates of adoption are different. The unorganized, the distributed, the marginal, the dissidents, the powerless, the criminal, they can make use of new technologies faster. And when those groups discovered the internet, suddenly they had power. But when the already powerful big institutions finally figured out how to harness the internet for their needs, they had more power to magnify, right? So the internet takes the power you have and makes it bigger. So if you have a lot already, you get more. So while it does give power to the little guys, it gives even more power to the big guys. That's the difference. The distributed were more nimble and were quicker to make use of their new power, while the institutional were slower, but were able to use their power more effectively. So while the Syrian dissidents used Facebook to organize, now the Syrian government uses Facebook to identify dissidents and try to shut them down. There's another more subtle trend that Bruce Schneier discusses in his books, Liars and Outliers. If you think of security as an arms race between attackers and defenders, technological advances like firearms, fingerprint identification, lockpicks, and radios give one side or the other a temporary advantage. Most of the time, the new technology benefits the attacker first, right? If you come up with a better lockpick, then you have that advantage until everybody replaces their locks with better ones, right? And so on. So it's the quick versus the strong. To return to the medieval metaphors, you can think of the nimble distributed power, whether marginal, dissident, or criminal, as Robin Hood. And you can think of the ponderous institutional powers, both governments and big corporations, as the Sheriff of Nottingham.
That's lovely.
Yes. And, sometimes depending on your view of it, the Robin Hood people are actually criminals that are stealing and maybe need to be stopped. But that is... they have the advantage of being able to kind of hit and run and be a lot harder to catch because there's just a couple of guys and they're spread out. And
yeah, very much so.
So Schneier asked, so who wins? What type of power dominates in the coming decade? Right now, It looks like it'll be institutional power. Mm-hmm. This is largely because leveraging power on the internet requires technical expertise, and most distributed power groups don't have that expertise. Those with sufficient technical ability will be able to stay ahead of institutional powers, whether that's setting up your own email server, effectively using encryption and anonymity tools, or breaking copy protection. There will always be technology that are one step ahead of the institutional powers.
So our audience.
Yeah. So our audience will maybe be okay, but what about the rest of the people? This is why cybercrime is still pervasive, even as institutional power increases, and why organizations like Anonymous are still a social and political force. If technology continues to advance, and there's no reason to believe it won't, there will always be a security gap in which technically savvy Robin Hoods can operate. But Schneier says his main concern is the rest of us, everyone in the middle. These are people who don't have the technical ability to evade either the large government and corporations that are controlling their internet use or criminals and hacker groups who prey on them. These are the people who accept the default configuration options, who agree to arbitrary terms of service, to NSA-installed backdoors, and the occasional complete loss of their data. In the feudal world, these are the hapless peasants. And it's even worse when the feudal lords, or any power, fight each other. As anyone who's watched Game of Thrones knows, peasants get trampled when powers fight. When Facebook, Google, Apple, and Amazon fight it out in the market, or when the US, the EU, and China and Russia fight it out in geopolitics, or when it's the US versus terrorists, or China versus dissidents. The abuse will only get worse as technology continues to advance. In the battle between institutional power and distributed power, more technology means more damage. Cybercriminals can rob more people more quickly than criminals who had to physically visit everyone they rob. Digital pirates can make more copies of more things much more quickly than their analog forebears, right? If I had to actually burn DVDs of everything I pirated, it takes a lot longer than if I'm just making digital copies. Right? Or 3D printers mean that data use restriction debate now involves guns, not just movies, right? So that's going to make a big difference there. It's the same problem as weapons of mass destruction fears, right? Terrorists with nuclear or biological weapons could do a lot more damage than terrorists with conventional explosives. The more destabilizing the technology, the greater the rhetoric of fear and the stronger institutional power will get. This means even more repressive security measures, even if the security gap means that such measures are increasingly inefficient, and it will squeeze the peasants in the middle even more. So it's exactly what we've been saying. As the government cracks down and tries to tighten things up to stop terrorists, the technology is allowing them to because of that gap, the disorganized people can always be ahead. And so tightening down doesn't hurt them, but the regular people who aren't that nimble are getting squeezed. So he says that transparency and oversight give us the confidence to trust institutional powers to fight the bad side of distributed power while still allowing the good side to flourish.
If we can trust that.
Yeah. Well, if they actually have transparency and oversight. And like you said, this is a political problem that requires a political answer. Like, more encryption isn't going to solve this. And it's the same thing, Paul Honeycamp's been saying.
Well, when he says the people in the middle, the people who accept the defaults, I really had that realization when the Snowden leaks came out a couple of years ago, and it became obvious that any non-secured means of communication, SMS, regular phone calls, regular SMTP email, they watch. And anybody who has even enough knowledge to use encryption, use maybe a VPN, maybe use GPG encryption for the things they transmit through the VPN or whatever, those people have a technological advantage that the average person doesn't have. And it really does become the have and have-nots. And the haves in this case are the people that have the technical knowledge that know how to use this stuff. And I think it's one of the reasons why they don't like programs like Telegram and Silent Circle and Signal and others to spread, because it makes it much easier for common folks to use some of those tools.
And we've seen them trying to push back doors into all of those.
Or fight them.
Yeah. So yeah, he says transparency and oversight give us the confidence to trust those institutional powers to fight the bad guys while still letting the good guys flourish. For if we were going to entrust our security to institutional powers, we need to know they will act in our interest and not abuse the power. Otherwise, democracy fails. And that's why it's important that while the government should do things to protect us or whatever, it has to be transparent, and there has to be oversight. We need courts that don't just rubber stamp their requests to spy on people, right? They say you have to have a good reason to violate this person's rights and so on, right?
Right.
I say, this won't be an easy period for us as we try to work these issues out. Historically, no shift in power has ever been easy. Corporations have turned our personal data into an enormous revenue generator, and they're not going to back down. Neither will governments, who have harnessed the same data for their own purposes. But we have a duty to tackle the problem. Then he makes a really good analogy here. He says, data is the pollution problem of the information age. All computer processes produce data. It stays around. We have to deal with it. We have to reuse and recycle it. We have to control who has access to it, how we dispose of it, and what laws regulate it. It's central to how the information age functions. And I believe that just as we look back at the early decades of the industrial age and wonder how society could ignore pollution in their rush to build an industrial world, our grandchildren will look back at us during these early decades of the information age and judge us on how we dealt with the rebalancing of power resulting from all this new data. I can't tell you what the result will be. These are all complicated issues and require meaningful debate, international cooperation, and innovative solutions. We need to decide on the proper balance between institutional and decentralized power and how to build tools that amplify what is good in each of these while suppressing the bad.
Well, this is a really interesting post by Bruce Schneier. I mean, really,
those
makes me
are
think.
only excerpts from it.
Yeah.
It goes on and it makes a bunch of good points about, cybercrime and so on.
The entire thing is worth reading because there is a lot more that we couldn't fit in the show. I guess too. I wonder if there's a book I've read that by Tim Wu, and it basically walks through how print and then radio broadcast and then cable TV all were hailed as the people's revolution, a new way to communicate, a new way to express ideas. It's going to tear down the barriers of the world. It's going to change everything. And all of those over time slowly became locked down by giant corporations and were controlled. Now, the internet is different in the sense that it's based on TCP/IP. And you can't really control and own the network in this particular case like you can with cable TV, radio, and newspaper distribution and whatnot.
It depends. If you get down to the 8 companies that run the internet backbones, then they do technically own the pipes.
But there's no one single company in a position to say this is what's allowed on internet and this is what's not allowed on internet, like there is for television and radio and print and all that kind of stuff.
Yep.
It's interesting, but it does seem to be historically what happens. Master Switch, by the way, that book, The Master Switch, Tim Wu, super good. Really recommend it.
Because print is gone. Originally, when it first came out, the printing press meant anybody could publish a book.
Yeah.
And then eventually you got to the publishing houses and distribution, and it became needed a publisher.
Yep.
Now we're getting to self-publishing, where it gets back to the point where you can actually make your own book and put it up on Amazon. Like the Sue Zedevets books I did were self-published by my co-author. And
it goes both ways, doesn't it? That's true.
So it's actually kind of got this. It started out very open, and then kind of got closed down, and then we fought it to get open again.
And we're still here, doing this now.
Yeah, he makes a bunch of points about blogging and podcasting and how that changed media in the article. But I can see all of it.
Well, you should have included a bit about podcasting, Alan. Come on now.
we can't have the internet go back to just being the Wild West, which works fine for our audience and me and you who have the technical savvy to protect ourselves.
Yeah.
But the people trying to do business, or just the regular people, are going to have all their things terrorized and all their money stolen or whatever. That's not going to work. But at the same time, we really need to convince people to not just end up where the internet consists of Facebook, Twitter, and Instagram, and that's it, or whatever, right?
Yeah, because it really otherwise would be a real real pale version of what was originally envisioned.
Yeah, basically we're going to end up with the AOL version of the internet, but there are 6 of them, and that's it. Or whatever. Basically, we're going to get down to like cable TV, where when cable first started up, there were thousands of cable companies, right? And there's a little one for each area, whatever. And now you have 3 choices. And we're basically going to get to you want internet, you can have Facebook internet, Google internet, or Microsoft internet. And
part of that is because of the revenue model that a lot of these online companies chose to go after, and it just sort of It's a tough business. Yeah.
Yep.
Well, that was a great post, and we have highlights in the show notes, but if you guys want to read the whole thing, it's linked as well. Any other thoughts?
Highly recommend that.
Any other thoughts on that one?
That's actually part of a whole series. If you go up one level in the directory there's a whole bunch of other stuff.
Okay.
I didn't get to read them all.
Oh, I see, yeah.
I saw one, another one besides Snyder's that's from the Prime Minister of Estonia, or President of, I don't know what the title is, but the current leader of Estonia. Because it turns out Estonia is a very tech-savvy country. Like, they have e-government everythand, like...
Cool.
Business completely online is very... because all their infrastructure is brand new, it's all modern. And with the fact that their president writes articles about the, greater glory of the internet.
That's pretty impressive.
That does bring us to the end of this week's TechSNAP. I hope you enjoyed this look back over 2016, and don't forget to join us next week. How could you forget? How could you? Go over to jupiterbroadcasting.com and subscribe to the RSS feed and get the show every single week. Then you don't have to worry about it. You can also watch it live. Go to the calendar page at jupiterbroadcasting.com/calendar to get that converted to your local time. And we love getting your questions via email. You can find that at our contact page. And last but not least, you can submit content at techsnap.reddit.com. Hope you have a great holiday. Thank you for joining us, and we'll see you right back here next week.